Coming in hot 18 hours ago, we have this email. Hello, the Cherno. I think this is some of the best C++ code ever written, or at least the best I can write. I thought they forgot, like, some of the best code I've ever written. Like, I just thought they forgot to say I've, but no, they actually meant that because they wrote, or at least the best I can write. So guys, brace yourselves. I wrote this chess engine back in September of 2024 in about 1 to 2 weeks, burned myself out, and stopped working on it until today. I was looking over my code and I had forgotten exactly how much effort I put into this project. I think this C++ code is near perfect. I follow all of the C++ standards and good practices and used modern C++ features. I love watching your videos. Your game engine series and OpenGL series is what got me into C++ in the first place. I am very proud of this code and it would mean the world to me if you reviewed it. You can be brutally honest, but don't break my heart. Okay, Nicholas. I remember in one of your videos you said Visual Studio files are not ideal. Here we go. It begins. But I don't know how to use a build system. Instead, I included the executable for your convenience. Wow. Everything was going so well until these 2 sentences. All right, so let's begin 2025 with something fresh. Now, I'll have a link to this repository in the description below in case you guys want to take a look at it as well. First and foremost, there's a couple things here that are wrong, possibly more than a couple. When you have a GitHub repository like this, the number one thing that you should have is a README. If you just make a file in the root of this repository called README, I think it can optionally have an extension like .text or MD for Markdown. That's the common thing that people usually use when they write readmes. If you just have a file like this, then you can have a section over here on GitHub, and in fact, pretty much any Git hosting website that allows you to write some stuff. So, for example, if we have a look at a repository I made called Walnut, you can see that we have that readme.md file, which is just like a markdown file. If we view the raw contents, you can see what it looks like. It uses the markup language called Markdown. Markup, but it's called Markdown. Anyway, it allows us to actually have this README thing with even images, links to various things. It's just a really good thing to have in your repository, especially if you are showing people this. So the reason why I mention this is because so many people put their code on GitHub in the first place because they want to perhaps like get a job interview or just have a portfolio of their work available online. And if you don't have a README like this, like, I don't know what this is, right? I don't know how to build it. I don't know what the features are. I would love to see a screenshot of what this looks like. I honestly think that's one of the most important things that you can do because first impressions and just taking something at face value is something that people do. Now, second of all, I don't like the fact that you have an executable here. Now, you mentioned that you did this for my convenience, which first of all isn't convenient for me at all because I'm not reviewing the executable. I'm reviewing the code anyway, and building the code is part of that process. So I've actually already got it open in Visual Studio. But second of all, instead of having executables here, you should use this little section here that's called releases, right? So you can make a new release. You actually do this using the actual GitHub interface. This isn't something that you do through Git, like through your Git client or through the command line, although you will need to make a tag. It's just something that you make through GitHub's interface, and it allows you to attach, for example, compiled binaries. That's what this is for. You shouldn't have those inside your kind of version control system. And the real big reason for that is because, I mean, usually pretty much every commit changes the code base. So for you to then build and include an executable that is, I guess, built from the current commit's source code is a little bit strange. And it also has no information as to like what, build configuration, what platform it is, anything like that. Then of course we have this chess console.sln file, which is a Visual Studio solution file, as you mentioned. You should prefer to use a build system, especially for something like a console chess game, right? Because I'm imagining this has 0 dependencies, right? I mean, it could use the Win32 API for certain console manipulation, like terminal manipulation things that might be operating system specific. I don't know. I haven't actually looked at this yet. But what I'm talking about is when we have like an actual GUI, we usually use other libraries, and then we have to make sure that they obviously build for certain operating systems. But this seems really portable out of the box is my point. But by making a Visual Studio specific solution and project files, you're limiting it obviously to Visual Studio and to Windows. Setting up a super simple build configuration script using a build system like CMake or Premake would just out of the box allow this code to be compiled using any compiler, any toolchain, and any platform. So that's your homework, Nicholas, is just to familiarize yourself with that, because believe me, in the long term, it's going to be very important. And then we have this how to make moves.txt file, which, look, I mean, hanging out in the root repository repository like this, I feel like the only kind of documentation you should have here is probably that readme.md file, as I mentioned, a license perhaps, and also, I mean, you could have like a building.md or some other kind of really critical stuff. Otherwise, everything else should be in a folder called docs, and this honestly you could just rename to like readme.txt at least, add some more information like a title, and just have it here, because I'm imagining this is some documentation as to how to use this thing. So this is going to be important later on when we try and actually play this game. Now, as we enter 2025, you know what another really good thing for you guys to be doing is? Learning. And that's where Brilliant.org, the sponsor of this video, comes in. Brilliant.org is an amazing website filled with lots and lots of really high quality courses on various STEM topics. And they have a 30-day free trial that you can use to check out their entire platform. I think Brilliant is an amazing place to start your programming journey because they have some really, really good computer science courses that don't teach any specific programming language, but instead teach you how to think like a programmer. Those are really the core skills which will then translate into other languages. And the best thing about Brilliant is that they teach you in a super visual, engaging, and interactive way. Rather than just sitting there and watching videos, you're actually engaging with the content. They're constantly quizzing you, they're getting you to drag things around. That kind of practical way of learning is just so much more effective. As I always mention, math is super, super important for programming, and Brilliant is one of my favorite places on the internet to learn math. All the way from the very, very beginning, if you're just new to math and it scares you and you need some help, to more advanced topics such as calculus, Brilliant's amazing way of teaching maps perfectly to all of these. And as I mentioned, Brilliant have a 30-day free trial that you can use to check out all of the courses on their platform and see if you like them. Just go to the link in the description below or use the QR code. Huge thank you, as always, to Brilliant.org for sponsoring this video. So now that we've criticized a bunch of this repository, let's actually take a look at the code. So over here we have the main file over here. If you are Cherno reviewing this, first of all, thanks. You're welcome. And second, I read that as wasn't because of the apostrophe. I want to point out why I think the C++ code is so good. Damn, this guy is serious about this code being the best in the world. I use const and const expert whenever possible. I try to avoid magic numbers, instead creating a header file called chess constants to store every reusable number. A header file called chess constants. Oof. Okay, we are going to take a look at this later. I tried my best to use the correct data type for every scenario using std uint32t whenever I don't need negative numbers, and std size t, or holy STDs, whenever I'm accessing an array or inside a for loop. The entire code runs on the stack. Oh, okay, well that is good. We'll expand on this entire code runs on the stack later, and I'll actually make sure that that's more or less the case, but that is really important for something like a chess engine, which we'll explore later. Finally, I make use of the most modern C++ features and try to use the most modern approach. The only thing wrong with the code is I was very inconsistent with my naming convention. For some reason, I kept switching back and forth between snake case and Galaxy. Surely you could fix that easily. I honestly don't know what, wait. Is this like you couldn't fix that? I honestly don't know what I was thinking. There seems to be no reason why I use one over the other, but hey, it is old code. Okay. I don't know if only using the stack was good or bad because it uses over 2.3 megabytes of stack. Well, you can always expand the stack really to be as big as you want when you actually build executable, so that's not really a problem. But I wanted the code to run as fast as possible, and most of the data is used up to the pre-generated moves, which needs to be accessed. Oh, okay, right, yeah. So of course, this is like a chess computer as well. It's not just like two players can play chess. There's like a computer kind of AI making moves as well here, not just humans. Because of that, I had to give the project more than the default stack reserve. Yeah, I gave it 4 megabytes, sure. I was following a tutorial. Okay, we got chess programming. He wrote, here's in C. I followed along in C++, making lots of optimizations and taking advantage of object-oriented programming. Whoa, that in one sentence is a sentence. The actual chess engine runs on bitboards, or even bro, the std namespace everywhere. I'll talk about types in the std namespace a little bit later, but this is just, no one really writes this. Like, people usually just write the types as this, and we'll see what your code looks like. It's one of those things that's like, I don't think it's strictly in the standard that's okay, but everyone does it, kind of like Pragma once, but we'll talk about it later. All the board data and move data is stored in this as well, so that it is fast and memory efficient. For example, the board is represented in just 12 U and 1 for. Okay, so I just want to quickly point out that I'm guessing this is a fairly inexperienced kind of early beginner to intermediate, maybe programmer, which is obviously totally fine. But the reason why is because there seems to be a lot of emphasis on, I mean, the whole stack optimization thing is a good idea, definitely. But there seems to be a lot of emphasis on, like, you know, I'm using things like const and const expert. Whenever possible, I'm using this data type instead of that data type. The thing is, like, what really matters at the core is, in fact, memory, which is why I mentioned that this is valid, right? But also the actual, like, algorithms that you're using, that is really the core of everything, right? So if you use one data type over the other, that's not really going to give you a speed up, right? I mean, it can in certain cases. As with everything I say, there are always but this or but that. But overall, I'm just saying that an experienced programmer would not be talking about their use of STD uint64Ts. That's all. And so I guess moving forward, I would definitely encourage you to probably not think so much about what you are using in C++ that could slow you down, meaning like, am I using the right data type or am I doing that or whatever else, but actually picturing what the CPU is doing with the code, with the compiled code, right? So the compiler produces machine code that runs as instructions on your CPU. That is what matters, right? And when it gets to that stage, the CPU is not like, oh, uint64T, let me just be really quick with this. It's the actual algorithms that you're running and things like memory fetches perhaps that are going to contribute either positively or negatively to your performance. For example, the board is represented in just 12 uint64Ts, one for every piece, where every bit represents a piece on the board. Okay, I think I see. This is kind of cool. So 12 is the amount of pieces in chess. I think he's saying that he's using 12 uint64Ts, and why 64Ts specifically? Because the chessboard is actually 8 by 8. So what we're looking at here is obviously like a matrix or an array of 64 different values, which is exactly the amount of bits that we have inside this unsigned 8-byte integer. So I think for every piece, for example, like let's just say the king. Where is the king? Well, we have to look at a single uint64T and then basically the bit that is active there. So we'll have a whole bunch of zeros, right? It's 64 0 ones. Right? So one of them is probably going to be 1, and then that means that the king is in that location. If I'm understanding this correctly. I mean, it does. Picture an 8 by 8 grid of bits. It looks like that's exactly what it is. I wonder why though, because that seems almost a little bit wasteful. I don't know. This is just thoughts that I'm having. Okay, let's get into this. So engine is created and given a fen, which is like a description of a chessboard, and fully implement that fen notation. So this is what it looks like. I know a little bit about chess engines, and I certainly know how to play chess, but I've never tried making a chess engine before, so we'll see how I go. And this is probably a good time in the video to mention that I'm going to be focusing on the C++ code, not an implementation of a chess engine, right? So I'm not going to be critiquing the actual chess engine architecture as much as the actual pure programming. Okay, so I think what we should do is we should try and play this. So using pre-generated magics, generating tables. Okay, so I think if we look at the how to make moves, okay, so this is a little bit annoying, but basically I think what it's saying is we need to pick a position. So for example, I don't know, this is probably where we are. Let's just say it's white's. I think it's white's move, but is this white? I don't know. Anyway, so if I want to move the king pawn over here, I think I type in E2 to kind of select it, and then E4 for where I want it to move to. Yes, that seems to have worked. So here I am. And then I think the computer is now thinking. Oof, my fan's just turned on. How long do we give it to think, guys? This is taking a while for the first move. Is it evaluating the whole possible game? We might need to run this in release mode because I'm in debug. Let's just hit pause for a second just to see what it's doing. This is another good way, by the way, to review or examine code or understand it if it's not your project, right? Just hit pause and see what's happening. And if your program stalls or if it's just doing something and you're like, what is it doing? Just hit the pause button. Just hit the pause button. It'll suspend all the threads. You can select whatever thread you want in this case, just dealing with the main thread. And then it will tell you, using the call stack here, what's actually going on. So right now, when I hit pause, we happen to be in pushing back this kind of move thing. But you can see in the bigger context that we're trying to do a step, and that's calling this minimax function, recursively it seems, to generate some possible moves. So minimax this is probably the extent of my chess engine knowledge, but minimax I know is an algorithm that basically tries to evaluate lots of different possible chess moves, kind of like building a tree of all the possibilities. I don't know how far it gets, and there's lots of optimizations that can be done to it, but that's what we're doing. So the step function, if we go to main, obviously engine.step is what we call here. This is inside the while true loop, which is the main kind of application loop that waits, I guess, for us to do something, because it's a console game anyway. So every time we write something in and hit enter, it's going to run an iteration of this loop, and then we're going to print thinking as we did, and then we're running that minimax algorithm here. So that's what this code is doing, and it seems to be taking a while as it goes through it recursively and tries to generate a bunch of moves. So if we look at the move list, but the move list is like there's 15 moves here, which, I mean, to be fair, how many possible moves are there? for black here, right? So each pawn, so there's 8 pawns, right? So 8 pawns can move either 1 space or 2 spaces. So that's 16 possible moves. Then we got the 2 knights, which can move into 2 different locations each. So that's 4. I think that's it, right? So that's 20 possible moves, I think, that black has at this point. Is that right? I think so. I don't know. So it definitely is seemingly taking a while. Let's try and run this in release. Okay, so I'll do the same thing, e2, e4. Thinking. Oh, here we go. It moved. Yay. Okay, so yeah, so I hope that just that there demonstrated to you how much of a difference debug and release is, right? Very, very important to know that. Okay, I don't know if we should continue playing this. I mean, I guess I can take the pawn maybe, and then black will presumably take with the queen. So let's try e4, d5. Okay, we have taken the pawn. Let's see how long this will take. Hey, nice, cool. Let's do b1, c3 to get that knight out to attack the queen. Will it withdraw? It's taking a while. Yeah. The curveball. Okay, it moved. Cool. Moved 1 over. And it actually checked us. Okay, cool. I'm not going to keep playing this. So let's have a look at some of the actual C++ code. And we could maybe start with chess constants since that was mentioned in the README. Okay, so pragma ones, we got a bunch of includes. We got using namespace, string view, literals. Look, I really don't like using namespaces in header files. String view literals, I'm guessing you've used because you wanted to use SV over here at the end of these strings, which is okay, but like, I don't know. How do you guys feel about this? Right? Because this is a specific, it's kind of like chrono literals as well, which I tend to only enable for certain scopes as I would with any other using namespaces. But then again, it's not like this is using namespace std globally. It's like a very narrow namespace that only includes like a few things like the string view literals. So what do you think? Do you think it's permissible to have a using namespace in a header file if it's something like string view literals, or would you definitely ban that? I'm kind of leaning towards banning it because really it's not necessary. The only thing that it does is it makes this code a little bit easier to read because you don't need to, for example, wrap all of these in string view. You can just use SV instead. But yeah, I don't know. All right. And then we have, all these STDs. Okay. So look, personally, I would write this like this. Yeah. Because these types like size T are implemented everywhere. Now, as I mentioned a little bit earlier, technically they're not part of the standard, right? So just like pragma once is not part of the standard, but you're using pragma once, right? So therefore you're definitely not 100% standard compliant. Is pragma once ever going to be added to the standard? I don't know. In fact, like what if I'm wrong? What if it already has been somehow added to the standard? I don't really keep up with these things. I apologize. But I would probably just drop the STD from everywhere. Like not obviously from like string because you need it for string, but like I would drop STD from these types like size T and UN64T. I think it's pretty much safe to assume they are in fact implemented everywhere. Other than that, I don't like the fact that these things are just floating around in global space. I think they should be in a namespace. This is what you probably meant by the naming convention as well, because you're not really like this is lowercase, whereas everything else is uppercase. But I don't really see too much problem with having like constants like this, just as long as they are in fact in a namespace. I also don't know if there's any value in having them const expr versus just const because they are just primitive types. Okay, and then we've got a couple strings over here. So this is interesting, right? Here you have an array of string views, and these look like different indices of the chessboard. This is what the chessboard looked like starting from 1. So this kind of top left coordinate over here, which is array index 0 inside the array of like the chessboard, is A8. That's like an alias for the name for it, right? And that goes all the way across the array basically to map an actual array index to like a name for that cell. So if, for example, you're at a coordinate such as like x equals 3 and y equals 7, then that in a single dimensional array, you would evaluate that as 3 plus 7 times the width, which is 8. So 7 times 8 is 56 plus 3, right? So you get 59. So in other words, array index 59, what is the name of that? And then you'd find it. You would just use that array index 59 as a lookup into this index, and that would give you, for example, E3. And then you're like, oh, cool, that's called E3. I'm guessing there's probably also the reverse of that if you have like E3 and you want to convert it to an array position, because obviously E3 is a position that we enter when we play the game. But anyway, the way that you're storing all of these is as string views, which is probably the best way to do this. So some alternatives that people would have is the first one that would come to kind of my mind would be using a const char pointer, right? Which is a kind of a C thing, but ultimately it's still a really good choice. Why? Because when you write a string literal like this, it's just stored in read-only memory inside your binary. So at compile time, basically, this string C5 is just going to be kind of baked into your executable. And then of course, when you start your program and the whole executable gets loaded into memory, you have a pointer, that's why it's a const char pointer, that points you to that particular string inside your read-only memory. So that's fantastic because obviously there's no like dynamic allocations, there's nothing like that. It's just, that's your string literal, it's there. However, the downside of using a const char pointer is that you don't know how long that string is, basically. You expect obviously that it's null terminated, so you can use like a function like strlen or whatever to figure out like how long it is, but you don't have that information automatically. With a string view, it's actually doing the same thing in this case. So it still sees that it's a string literal, obviously. A string view, by the way, for those of you who don't know, maybe I should have explained this, is basically just a const char pointer. I'm sure it probably supports other character types as well, but it's just a const char pointer and a size. So it's just got that, and it's non-owning, meaning that like it doesn't own the memory, it doesn't potentially allow you to even manipulate the string. It's just a view into an existing string, whether that be like a dynamically allocated string that you can modify, whether it be a string literal like this that's stored in that read-only memory. It's just a view into a string, but critically it has that size variable that allows you to actually be like, okay, well, how long is this in case I need to like render it on the screen or something. So ultimately, that's why I would prefer to use string view over const char pointer, just because it doesn't really have a performance penalty for us, but it does provide us with more information. Now, it also provides us with the whole C++ library's string manipulation functions, right? Because a lot of them take in string view as an argument, but obviously with const char pointer, you're basically forced to use like the C style functions, which in general are less extensive. Like you might not be able to do all the things you want to do, whereas you will with a string view. Now, finally, I'll obviously mention why std string would be bad. And I guess I probably would call it bad. The reason why is because std string is a mutable string. What that means is that it has to be modifiable. This is supposed to be obviously a read-only string literal. There is no place in this program where we would ever be modifying this because it doesn't make any sense for us to modify it. However, if we construct an std string out of a string literal, it's going to copy that memory so that we have the ability to modify it if we so choose. So technically speaking, if anywhere in your code base you have a string literal or you have like a const string that you never want modified, std string is always the wrong choice. Now, the performance hit technically wouldn't be that bad in this case because even though std string a lot of times will allocate memory on the heap to store your dynamically sized string, if you construct std string with a string that is small enough, such as this one, this is very small, it's 2 characters, it will use this like small string optimization thing, which basically means that std string actually has a buffer on the stack that it can use to store strings up to a certain size. And I think it's like pretty decent. It's like either 16 bytes, 16 characters, or like 32 characters. Okay, so doing a little bit of research, the size of this small string optimization buffer is 15 bytes in GCC, 23 bytes in Clang, and also 15 bytes on 64-bit MSVC. So we're using 64-bit MSVC here. So 15 bytes, 15 characters is like the maximum allowable size for it to fit into this small string optimization thing, which just means it'll use that stack buffer rather than allocating a whole new buffer on the heap when you try and construct that string. This is just an episode about strings. So in conclusion, you would definitely prefer to use string view here like this person has, which is great. I just think that this is something that definitely comes up a lot of like, I'm trying to make like this string or whatever, or what do I use because there's so many options. So hopefully that clears it up. That being said though, and why I even brought this up in the first place is because you have these strings here. And I just don't understand why. So these will be heap allocated buffers. That's the thing, right? So this string, because you're taking a string that is obviously more than the 15 bytes or more than the 15 characters we've just talked about, and then you're assigning it to an std string, but then you're kind of writing const here, which tells you that you don't want to modify it. Obviously, it's supposed to be a constant, and in fact, it's a fen, it's a start position, right? So obviously, this is not something you'll ever be modifying. This is like basically preset game worlds, preset scenes that you're trying to load. They should also be string views because this is supposed to be something that you just store in your binary. So over here, I have a hex editor called hxd, which I love using. And then if I grab the binary, so this is the release binary that we actually constructed. If I grab this this and I drag it in here, then guess what we are going to find in here. So if we grab like a portion of this and we search for it, then check this out. Over here in this section where we have all of our strings, we're going to find that exact string just sitting there inside our binary. There's 2 of them probably here. And then over here, for example, was that array of all of the positions, and there's like more strings here and everything, right? So we're actually storing these already inside our binary that get compiled into it. And instead of just having a pointer to it like you would here, you're actually copying this into, in this case, a heap allocated buffer that is modifiable, even though you're trying to use it as a const string. Right? So definitely not an attribute of the best C++ code in the world, but also, yes, fundamentally, it's not really going to matter that much as a starting position, right? It's like a string that maps out a starting position that presumably is going to be used a single time on startup. So is this going to improve the performance of the code at runtime? No. However, it's a good thing to just be aware of, obviously, especially if someone is in fact critiquing your code and you want them to be impressed. Okay, the other thing that I noticed here, which is really, really good, is you've got some const expr functions. So you have a const expr array, create character, I guess, or create char, yeah, sure, character to piece. And we have this like table here, which we fill with a whole bunch of different things here. This is interesting because it's a mapping from an actual character. I don't know how I feel about this overall. I actually didn't notice because I was going to point out the whole const expr thing, but I didn't notice this overall. But you're using characters as an index, which is why this has to be 128 or whatever, because some of these characters are like, 113. So the whole array is just this many values. It's 12 values, but you've allocated 128 of them because you're trying to use the character as an index. So typically you would use a map in this case. However, you may not want to use a map due to the complexity of a map, right? So if you want to retrieve or add stuff to a map, obviously that has to go through more kind of processing than just a simple integer index like a character would be. So I actually don't mind this too much. And again, the fact that it's created once as a const expr is good. But the thing that I was really wanting to point out here is that some people don't realize that it's not really enough to just create a const expr function. You need to actually create a const expr variable that maps to that function. Because if this is in fact a const expr function, but I call this function in my code, just in my runtime, it's actually going to evaluate this at runtime. So const expr in this case just lets us either do this at compile time or at runtime. It doesn't mandate it to be done at compile time or anything like that. However, having this piece of code here, an actual const expr std array that is an actual variable that is mapped to that function, means that this and all of this code will run at compile time, and the result obviously will be stored inside this const expr variable. So that is super important, and this is a mistake I see often as well. So it's really good to see that the author of this code hasn't forgotten that and has actually assigned this const expr function to an actual const expr variable, ensuring that it's done at compile time. And of course, I would expect going forward, this is the variable that he would use to reference this function instead of ever calling that function really again, which is why another idea might be to put this into like some internal or detail or whatever namespace that hides this more or less from the public so that you're not tempted to accidentally call this. In fact, all of this really needs to be in namespaces, right? So definitely get used to using namespaces. Okay, so there is a lot more that we could obviously take a look at. So let me know guys in the comments below if you want me to continue reviewing this particular project. I think what I probably want to take a look at next time is this whole like stack memory, everything running in stack memory, which we've already proven is somewhat not correct because obviously like we have this string that is literally on the heap for no reason. But otherwise I would really like to take a look at like the memory layout. Maybe we can actually dissect that next time. What did you guys think of the code that we've looked at so far? Did you like it? Does it fit your idea of the best C++ code ever? If not, definitely leave your feedback in the comments below. If you want to send in your code for me to take a look at, as always, you can do that by sending an email to chernoreview@gmail.com. That email address and some instructions will be in the description below. Thank you guys for watching. I will see you next time. Goodbye.